We are on the third lesson of the 7th chapter of the Pearson Geometry video series. In Chapter 5, we discussed reasons for triangle congruence. Reasons like side, 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 angle, 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 side, and hypotenuse leg. In Chapter 7, we will prove that triangles are similar, using very similar sounding names. Theorem 7.1 is angle-angle similarity. In Theorem 7.1, we have if two angles of one triangle are congruent to two angles of another triangle, like angle B is congruent to angle E and angle A is congruent to angle D, then the two triangles are similar. That doesn't prove that they're the same size, but they're the same shape. In Theorem 7.2, side, side, side similarity says if the corresponding sides of two triangles are proportional, then the two triangles are similar. So if AB is to DE as BC is to EF as AC is to DE, or in other words, if all of these are congruent fractions, then we have two similar triangles. And finally, 7.3 says in side, angle, side, if one angle is congruent to one angle in another triangle, and the sides that include the angles are proportional, then the triangles are similar. So it's kind of a combination of these two. So in this drawing down here, we have angle B and angle E are congruent. So if BC and EF are proportional to AB and DE, then the two triangles are similar. So let's take a look at example 1. In example 1, we're given all of the sides. So we can use theorem side, side, side in order to see if these two triangles are similar. So instead of trying to match up the sides based on how they look, let's go by the names of the triangles because these are supposed to be in order. So we can say AB over DE. So AB is 3 over DE, which is 4.5. And that needs to be equal to BC over EF. So BC is 4 and EF is 6. And that needs to be equal to AC over DF. So AC is 5 and DF is 7.5. Now the easiest way to check these is to just reduce them. So if we put these in the calculator, 3 divided by 4.5 is 2/3. 4 divided by 6 is 2/3, and 5 divided by 7.5 is 2/3. So since they all reduce to the same fraction, we can say yes, they are similar. Which, by the way, the similar sign, if you remember from 7.2, is like a congruent symbol minus the equals. Okay, let's take a look at example 2. In example 2, we have a combination of two triangles here. And so what we want to do is separate these triangles. So we've got PQS, and actually it doesn't matter if you draw them exactly like they are or not. So I'm going to draw PQS right here, PQS, and then I'm going to draw RQP the same way. RQP. All right, now I'm going to add my sides based on what I have up here. So P and Q are 18 in both of these, and RQ is 12, and SQ is 15 plus 12, so that's going to be 27. Okay, now we also have angle Q, which is in both of these. So we're looking at the two sides that include angle Q, which is congruent in both triangles. So we can say 12 over 18 is equal to 18 over 27. And if we reduce these, and this is just a coincidence, but 12 over 18 is equal to 2/3, and 18 over 27 is also equal to 2/3. So yes, these are similar. Okay, let's take a look at the next page. Okay, so this is verifying triangle similarity, which is actually what we were doing in the last two examples also. So in example 3, part A, we are comparing triangle ADE and ABD, and since these are all together and that's really hard to look at, first thing we want to do is separate those triangles. So we're going to start with, and like I said, I just draw two triangles. So ADE, and then another one, ABD. Just make sure you draw them in the same order. So ADE and ABD. Okay, so we've got ADE. So let's look at AD and AB. So AD is 2.4 and also 2.4 here. And AB is 3.2 and AE is 1.8. And in both of these we're looking at isosceles triangles. So DB is also 2.4 and ED or DE is also 1.8. So we only have to check one. So we're going to say 1.8 over 2.4 is equal to 2.4 over 3.2, and then if we reduce those we get 3/4 equals 3/4. So yes, these two triangles are similar. Okay, and in part B we have some congruent triangles, or congruent angles at ADE and BDC, so those are the two that we're looking at. So if this is the angle, then these are the two sides, and if this is the angle, then these are the two sides. So we want 1.8 over 1.4 equal to 2.4 over 2.4. Okay, those are not going to work out. So that's going by how it looks. So let's fall back on what we have here. So AD over BD, nope, still going to be 2.4 over 2.4, and then DE over DC is going to be 1.8 over 1.4. So this one is not similar. Okay, let's take a look at finding lengths in similar triangles. Okay, so we have two isosceles triangles. So we can say that JKL is similar to triangle MNL, and we can compare those sides to find the missing length. So we are looking for MN. So we can set this up as MN over 10 is equal to 1 over 75. And then if we cross multiply, MN is going to be equal to 10 over 75, which is going to reduce to 2 over 15. So MN is equal to 2/15. All right, now let's take a look at the same problem from a different angle. Let's say that JL, which is right here, doubles. That would make it 150, and JK stays the same. Okay, so we would still set it up as MN over 10 is equal to 1 over, and now JK is doubling, so that would be 150. So we can multiply both sides by 10 again, and we get MN is equal to 10 over 150, which equals 1/15. Okay, so how does the value change? We started out with 2/15, and then when we doubled the long side, we ended up with 1/15. So MN equals 1/2 the length. Okay, then looking at part B, let's say that JL remains the same, but JK doubles. Okay, so we're looking at MN over 20 equal to 1/75. So in this one, we're going to end up with MN equals, we'll cross multiply, 20/75. And so that's going to be equal to 4/15. So now looking at it, now MN equals 2 times the length. Okay, those are all different ways to look at finding lengths in similar triangles. The last one is a word problem. It says Avery puts up a radio antenna in his yard, or radio tower in his yard. Ella tells him that their city has a law limiting towers to 50 feet in height. How can Avery use the lengths of his shadow and the shadow of the tower to show that his tower is within the limit without directly measuring it? Okay, so what we're using here is 2 right angles, which are in the picture, but just in case you can't see them. And so we want to see if the legs are proportional. And we can figure out if the legs are proportional by setting up a proportion and figuring out what ST is. So let's say that we'll just call this unknown side here ST. And we will put that over 40 and set that equal to Avery's height, which is 6, over Avery's shadow, which is 5. And then cross multiply, so we get ST is equal to 6 times 40 is 240 over 5, which reduces to 48. That means that ST, or the height of the tower, is equal to 48 feet. So, is Avery within his legal rights to have that tower? And we're going to have to say yes, because the tower is less than 50 feet. And that is all there is to similar triangles. So, see you next time.